So again, we see that we have the point t, y of t. For the specific function, y of t is going to be 0.015 t squared minus 2.15 t plus 100. And we're going to have the point t plus delta t, and y of t plus delta t, where y of t plus delta t is an expression that we're going to have to work on a little bit. So we have a question mark here. Okay, well, the question mark, the y of t plus delta t, we simply plug t plus delta t in instead of t in this expression, and we obtain 0.015 times t plus delta t squared minus 2.15 times t plus delta t plus 100. Then we simply do a little bit of algebra. If we square t plus delta t, we get t squared plus 2t delta t plus delta t squared. We distribute the negative 2.15 through this addition. We get negative 2.15t minus 2.15 delta t. The 100 just comes down. We distribute the 0.015 through this expression, and we get what you see here. And there's a plus 100 on the end over there that we didn't quite have room to include, but you can just about see it all right here. And that is the expression that would go in for y of t plus delta t. In another example, another model, we might have a function y equals 2t squared minus 3t plus 5. And we could do the same sort of substitution, and we get some results here. When we subtract y of t from y of t plus delta t, we get y of t plus delta t minus y of t. We put this whole expression down for y of t plus delta t, then this expression for y of t. Now let's look at what happens when we put those expressions down, because this is what happens anytime we do this for a quadratic model. We see that the 2t squared and the 2t squared, the 2t squared from the y of t plus delta t, the 2t squared from the y of t are identical, except this one's grouped in a subtraction, so they're going to cancel out. The 3t and the 3t, same thing. Negative 3t minus a negative 3t, and the 5 minus a 5, leaving us only with the orange circled parameters, or terms, 4t delta t plus 2 delta t squared minus 3 delta t.